Okay, so the problem asks, find the radius and the interval of convergence for the series. F of x is equal to the sum of n equals to 3 to infinity of negative 2 to the n times x plus 1, x plus 3 to the n times natural log of n. So the first step is to apply the ratio tests. So what the ratio test tells us is that the limit as n approaches infinity of a n plus 1 divided by a n has to be less than 1 in order for it to converge. So if you take this to be our a n, then the limit as n approaches infinity since the ratio test only takes the positive terms, we can take out that negative from the original series. So we will get that the limit as n approaches infinity of 2 n plus 1 times x plus 3 n plus 1 divided by n plus 1 times square root of n that times the reciprocal of the original series, which is n plus natural log of square root of natural log of n divided by 2 to the n x plus 3 to the n. So we know that this cancels with that, this cancels with that, and this does not cancel. So this will be equal to the limit as n approaches infinity. We keep the 2 and the x plus 3 on this side. So we'll get 2 x plus 3 times n times square root of natural log of n over n plus 1 times square root of. Okay, so now this limit, that's the limit that we want to solve. So if we take this limit and we bring it back here, and we do it separately, we'll get that the limit of that is just equal to infinity over infinity. So we have to apply the L'Hopital's rule. So this will be equal to limit as n, so this will give you ln 1/2, and then you apply product rule, then that will be equal to plus n and that's n over 2 times ln -1/2. Yes, n times 1 over n from the product from the chain rule, and then from the bottom we'll get ln n plus 1 to the 1/2 plus, in this case we'll get n plus 1 over 2 ln n plus 1 to negative 1/2 times 1 over n plus 1. So this n cancels with that cancels with that, and we can't do anything with that. So this limit, since these are on top, this will also equal to infinity over infinity. So we have to apply L'Hopital's rule one more time. So this will equal to limit as n approaches infinity, and we apply chain rule. So we'll get 1/2 will be equal to 1 over 2 to the minus, so it's equal to L, and 1/2, same on the bottom, equal to 1 2. And then we do the other side, and we get, so minus, so 1/4 times natural ln to the minus 1/2 minus 1, that will be equal to minus 3 over 2, so 3 over 2, and oh wait, I forgot something. And so this limit gives us, okay, so since all of the n terms are on the bottom for each term, then we'll just get 0 over 0, which is just equal to 0. And all of this has to be less than 1 according to the ratio test, so it has to be less than 1. So 0 is always less than 1, so that r is equal to 0, and the interval of convergence is equal to infinity. Understood. So r is equal to infinity, and the interval of convergence is equal to infinity minus infinity to infinity. And we can see that this is true since if 0 is always less than infinity, if 0 is always less than 1, then the radius of convergence is always going to be infinity, and the interval convergence is always going to be minus infinity to infinity, since this series converges for all terms of n of x.